Check this out. It's a retro calculator from 1977, the TI-1025. Here is the date code, week 47, year 1977, made in USA. Nice. The main reason why I want to pick one up is because of this. It's got a VFD display. So let's check it out up close. Nice green retro VFD display. So these were made cheap and plentiful back in 1977, and the amazing thing is you can still find these cheap and plentiful in the current year, 2025. You can find these for like 10 or 12 bucks on eBay. So it's a basic 4-function calculator with memory and 8-digit display. And if we try, let's say, divided by 3, you can see it counting. You can see it counting the numbers on the screen as it's thinking. Let's 2 divided by 3 again. So let's test the most important reason why you want a calculator. Let's say you go out to dinner, spend 90 bucks, and you want to leave a 20% tip. So you just do plus 20%, that's the tip amount, equals $108. Do something crazy like divided by 0. Here is how the calculator yells at you, gives you an air condition. So it runs on a 9-volt battery, goes in right here, and in case you want to know what it looks like inside, pry out the tab here, take out the battery, and then there's 3 tabs up here on the back that you have to pry, and the back cover pops off right here, and then you can slide it forward and it releases 3 more tabs on the bottom right here. And it's going to look something like this. So here is the brains of the calculator right here. So this is the keypad. It's connected by these wires to the circuit board, and really that's all there's to it. Here's some capacitors, resistors, diodes, the display, and under the display is the main microcontroller. That's the actual brain of the calculator. So we can look up close at the display. Here's where the 9-volt battery connects, and there's a power jack, so you could connect it to a DC voltage power supply. And I know somebody's going to want to know the answer to this. How much current does it draw from a regular 9-volt battery? And I measured it at around 17 milliamps. So a battery like this is around 500 milliamp hours. So we'll do 500 divided by 17. So at best case, like theoretical maximum, that's like 29 hours battery life. But I mean, realistically, let's do times 0.8. So like 23, 24 hours, that's about the battery life you can expect. So another cool thing about this is it has an internal precision greater than what it displays on the screen, which even a lot of modern basic calculators don't do. For example, 1 divided by 7, it's a repeating decimal, but if you multiply it times 10, well, the last digit becomes 4, and that's actually the correct result. It's one of those numbers that just repeats forever. So it operates pretty much like a modern basic calculator, except it does not have a square root feature. So we're going to use this as a learning opportunity, how to do square roots without a square root function. And we're going to demonstrate this using this modern calculator. So let's say we want to find the square root of 2500, which is 50, but let's say we don't know what the answer is. Well, we need that number and a guess. So for a guess, let's say we take the half the digits of our original number, which could be 25. So 25, and we're going to store that as a variable a. So then we're going to do 0.5 times 2500 divided by our guess plus our number that we guessed. We're going to get back a number, and we're going to use this number as our new guess. So we're going to store that as our new variable a. And then we're going to go back and repeat it 3 more times. Run that, and look at this. Now we're much closer to the actual value. So we store this as our variable a. Now we run it a 3rd time, and look at this. We can pretty much ignore all the decimal places once we get a 0 as the first digit after the decimal point. So let's just try it again. Store that as A, and watch this. We run it a fourth time, and look, that's impressively close. So that's called the Newton Raphson method of square root approximations, and it works surprisingly well. So let's say you want to find the square root of 5200. Well, we don't know what it is, but we're going to use 52 as our initial guess. So 5200 divided by 52 plus 52, and that total divided by 2, that's our one cycle, and we're going to store it to memory. So let's do it again. 5200 divided by, recall our memory, plus, recall our memory, divided by 2. Look, we're already close. And we're going to clear our initial memory and store this as our new memory. So let's do it again. 5200 divided by memory plus memory divided by 2. And now watch, we only done it 3 times. Now let's compare. 72.111 and 72.111. That's surprisingly close. So there you go. You get to watch retro tech and you get to learn math. If you like the video, comment, like, and subscribe, and we'll see you next time.